you're going to ask questions. So what makes a rational function rational is it's a fraction that has an x in the denominator. So everybody look right here. We're going to be graphing these pretty intense graphs. They look harder than they are. If you can remember all the tricks, it's actually really easy. So everyone needs to listen hardcore, because if you don't catch on to the tricks, you're going to be a lost soul. And this is half your test. So first things first, I want you to look with me at vertical asymptotes. Here is a vertical asymptote and here's a vertical asymptote. Correct, everyone? Yes? Okay. Vertical asymptotes, notice, are going to help shape the graph. And I want you to notice something. On both sides of the vertical asymptote, this is going in the same direction. Are you with me? And then look at this asymptote. On both sides of the asymptote, aren't they going in opposite direction? Oh,
wait, I don't think we have the notes. It's
exercise.
It's 3.1.
No, those, wait. You just need the notes.
Yeah, well,
Okay, they're right here. Come grab them. Is that why no one's actually participating? Because you're all looking around confused. Okay. Okay, so back to it. I need you to, this is wildly important to catch on to. Do you guys agree that on both sides of the asymptote it's going in the same direction? Do you see what I mean by that? And then look, on this side of the asymptote, it goes up. On the other side of the asymptote, it goes down. So on the vertical asymptote, if it goes in the same direction, you're going to know because that asymptote is going to show up, and I'll tell you where it comes from in a minute. The asymptote is going to show up an even number of times. So let's say it's at x equals -3, x equals -3. That would be happening twice. You would then say to yourselves, when I go to graph this, we got to go in the same direction. Now that could be up and up or down and down, but they're going to go in the same direction. And then notice if they're in the same direction, they're like next to each other. Where if an asymptote happens an odd number of times, a vertical asymptote happens an odd number of times. See, this is at x equals 2. So if it was x equals 2, x equals 2, x equals 2, that would have happened 3 times, which is an odd number of times. You're going to know for a fact that it's going to go in opposite direction at the asymptote. One will go up, the other side will go down, and they'll be like in opposite areas. So it wouldn't look like this. Some kids know this idea, then they'll get to the test and they'll go like this. This one's up and this one's down. But do you guys see how they're in the same position? That's not possible. That would be down on the other side, like clear down here. Does that make sense? Opposite quadrants if they're opposite. All right, so look right here. At the vertical asymptote, aren't they in opposite direction? And same here. Okay, that's going to be really helpful because in a minute when we know that, and once we get this side drawn, we'll then be able to draw the other side because we'll say we're going down like that. All right, so is this one going in the same or opposite direction? Same. And this one's going in opposite. So that'll help us later when we get to graphing. Okay, now we're going to go to horizontal asymptotes. What I want to point out is a horizontal asymptote actually does not help shape the graph in the middle of the graph. Horizontal asymptotes aren't are not going to help you shape your graph in the middle. So horizontal asymptotes can get crossed. Vertical asymptotes do not ever get crossed. Horizontal can. So look right here. Do you guys see how the horizontal asymptote's getting crossed in the middle? It's because the middle has nothing to do with the horizontal asymptote. Literally scribble all this out. The horizontal asymptote just guarantees you're going to approach this asymptote clear out here on the left and clear out here on the right. So it only guarantees that our graph will come to this asymptote out here and out here. So just keep that in mind. See, look. The horizontal asymptote is right here. They didn't draw it in, but it only guarantees that we're going to be near the horizontal asymptote out here. The middle can cross it, and it might not. It just has nothing to do with the middle. See, look right here. Isn't the horizontal asymptote getting all crossed and stuff? Yes? But look, when we go out here and out here, it definitely approaches the asymptote. That's the only thing a horizontal asymptote helps you with is the ends of your graph. So we got to get right to the point. Where are vertical asymptotes? Well, I'm telling you now. Vertical asymptotes, the one that go like this, are domain restrictions. They come from the bottom restrictions. So we factor the bottom to be x minus 3 and x plus 1. I'm factoring a lot of things for you quickly today because we don't have time to do a times c adds up to be b. So right here, if we factor the bottom, we can then find the restrictions. What are the 2 restrictions? So x equals 3 and x equals -1 are going to be vertical asymptotes. How you're going to know if they go in opposite direction or same direction is how many times the asymptote happened. Didn't each of these happen one time? So we're going to say that they're going to go in opposite direction. That's going to be wildly helpful when we go to graph, because if we have one side of the asymptote drawn, we then jump to the other side and draw that in. All right, see, this bottom factors to be x plus 3. x minus 3. So our two vertical asymptotes are at x equals positive 3. Oh, right here, positive 3 and x equals negative 3. They each happened one time. So that means that they go in opposite direction. Because these are domain restrictions, that's why vertical asymptotes never, ever, ever, ever get crossed. Now think about it. If we know our domain restrictions are vertical asymptotes, see, notice this is the same problem. They're going to ask you then to just state the domain. They won't even make you graph it sometimes. They'll say, what's the domain? Well, the domain is everything but 3 and negative 1. So look, if you use this visual once, usually you don't have to draw it again because you get the picture. We know domain will be everything except negative 1 and 3. So our domain will be negative infinity to negative 1, jump over negative 1, head to 3, jump over 3, head to infinity. So anytime you're asked the domain, you're always going to jump over the restrictions. You're going to go from left to right, jumping over the restrictions. So if these are the restrictions, what would be the domain on this one? Negative infinity to negative 3, then from negative 3 to 3, then from 3 to infinity. Do you guys feel like you need more examples of finding vertical asymptotes? They come from the bottom restrictions. Then our domain will be connecting from left to right, jumping over those values. Do you think you've got the vertical asymptote thing? Okay. If you were to have imaginary vertical asymptotes, see, this doesn't factor. It is 2 perfect square roots, but it has an addition sign. So these actually have imaginary solutions. Picture me setting it equal to 0 and solving. I would minus 1. Let's say I solved by not factoring, since it doesn't factor. See, our solutions are imaginary. There's no such thing as an imaginary vertical asymptote, so there are none. There are no vertical asymptotes, which means the domain has no restrictions. So the domain would be negative infinity to infinity. Horizontal asymptotes are end behavioral asymptotes. They just tell you end behavior. So now we're going to go learn how to do horizontal asymptotes, and it's a lot more in-depth, not super in-depth, but it's not as easy as it's the domain restrictions. It has nothing to do with restrictions. Now, here's what I want you to think about, because this is an idea I use. So, horizontal asymptotes tell us what y value our graph will be at really far out to the left and right. You don't need to do both because it approaches the same value. So I just say, let's plug in a really big x value. Is x equal 100 pretty far out here? So if I plug in 100 and calculate it and the y value is 0.9999999, isn't that approximately 1? Do you guys see what I'm saying? Now, do I really want to plug in 100? No. So I think deeper. I mean, easier, really. I go plug in 1 billion. Why? Because isn't 1 billion going to be dang close to the correct y value? Because you're going clear far out to the right, everyone. If you go further out to the right, you're getting closer and closer to the horizontal asymptote. So I go plug in 1 billion, and then I just calculate it in my head. Why can I do it in my head? Because I don't need the actual number. I just need to think about what's happening. So let's go to that. Skip all of this and go straight to horizontal. So with horizontal asymptotes, there are 3 things that are going to happen, and I don't memorize these rules. I'm going to just demonstrate the 3 things that could happen, and then you don't have to memorize anything. Now, I need you to listen very carefully. I just told you, since we're looking at how far out to the left and right this goes, like what's the y value really far out to the right and left, I go plug in x equals 1 billion. So watch, if I go plug in 1 billion, that would look like this. 3 billion squared plus 1 billion minus 2 divided by 4 billion squared minus 1 billion plus 1. Now, here's what I need you to realize, okay? If I said to you, calculate this in your head, you totally can do it. You just don't realize you can. Because here's the thing. Wouldn't you agree that let's just focus on the top for a minute. Isn't 1 billion squared 1 billion times to 1 billion? Yes or no? Okay, now you have to realize that that's so freaking large that your brain, truly your human brain, can't comprehend how big it is. You can't even visualize it because it's so big. So if you take 3 billion squared and then you add 1 billion onto that, the plus 1 billion doesn't really change the value of 1 billion squared. That's like taking an ocean and taking an eyedropper and putting a drop of water in. Would a drop of water change the ocean? It's still the ocean. So this billion is so small in comparison to 1 billion squared that we just ignore it. We're like, we don't care about that. It's not going to change our approximation. This used to bug me even as a new teacher, but it was when I realized that my brain couldn't see how big a billion squared is that I was getting weirded out by ignoring a billion. Do you guys see what I'm saying? So if you realize that this is so freaking huge that you can't even realize how big it is, then it makes sense of why, oh, that's billion is actually teeny in comparison. -2 is so small in comparison, we just ignore it. So my point is, if we're plugging in a billion, the leading term is gonna be freaking huge compared to everything else, that if we're just doing an approximation, we can ignore anything but the leading term. So we actually just do leading term divided by leading term. Let's go back to x's. So that would be 3x squared is the leading term on top divided by 4x squared. This is what matters since we're plugging in a billion. So what does that calculate to be? Everybody look, don't overcomplicate it. What does that simplify to be? Don't the x squareds divide out, everyone? 3/4. Oh, you just got an approximation. 3/4 is what it's going to approximately be. So y equals 3/4 would be your horizontal asymptote. Does that make sense? Divide leading term by leading term. So on top, if it's factored, you've got to actually multiply it together. On top, we have x squared. On bottom, we have x squared. I'm not distributing anything else out. I only need the leading term for horizontal asymptotes. So I actually would just say that's all I need. So what is x squared divided by x squared? 1. We would have a horizontal asymptote at 1. Okay, look at this one. The only thing that matters is leading term divided by leading term. So what happens with the x cubes? They divide out perfectly. So 6 divided by 2 is 3. We would have a horizontal asymptote at 3. So this case number 1 is when the power on top and bottom are the same. You'll notice if the power on top and bottom are the same, they just divide out and you just divide your leading coefficients. But there's no memorization needed, you just do the math. Now watch case number 2 here. See, the degree on bottom is larger than the degree on top. Let's look at what this would look like. It's the same thing though. We're looking at what's the calculation really far out. So if we plug in x equals a billion, we only care about the leading term. So on top we have leading term x, on bottom we have leading term x squared. Nothing else matters besides the leading term. So then simplify it. That's x divided by x over x. Don't these x's divide out? So we have 1 over x. So when we simplify this time, you're not getting a number. So the question is, what are we getting? Well, go plug in a billion into 1 over x. What's 1 cut up into a billion pieces? One single piece of bread is getting cut up into a billion pieces and given to a billion people. They each get a little piece of bread. How much bread are these billion people getting? Nothing, a freaking molecule, right, everyone? So you would say that calculates to be 0. So if you simplify and you have an x on bottom, you're cutting up your top so freaking much that it's going to be approximately 0. You would draw in a horizontal asymptote at 0. See, that same thing happens here. If I say leading term is what matters for horizontal asymptotes, which is always true, our leading term on top would be 1, our leading term on bottom would be x, so that would be 1 divided by a billion, which is 0 again. Do you guys see what I'm saying? So if the degree on bottom is still an x and the top is not, or if the, you know what I mean, then for sure it's going to be 0. So on top, we actually have 3 times x, which is 3x squared. On bottom, we have x cubed, because we know the only thing that matters is the leading term. So if you look at that, won't that be 3 over x once we simplify? Right? There's 2 x's on top and 3 on bottom. Do you guys see how it's 3 over x? So what would that be if I plug in a billion? 0. Okay, we get the picture. That's case number 2. If the bottom still has an x on it, it's going to be 0. Case number 3 is when, look, let's do leading term divided by leading term. If you do leading term divided by leading term, don't we get x? That's not the same as 1 over x. 1 over x was 0 when we plug in a billion. Right here, if we plug in a billion, we get out a billion into, we're plugging it into x. If we plug in 2, we get out 2. So we plug in a billion, we got out a billion. When we plug in 2, we got out 2. Isn't that actually creating a slant, everyone? Which makes sense. What is x? Isn't x to the first? Isn't that by definition linear? So if you have an x on top, it's a line. What if it would have been x squared on top? What would the shape be? A quadratic, right? A parabola. Do you guys see what I'm saying? So in this case, there was an x on top, which made it linear. So then guess what we actually have to do? We actually go find it. We have to go like this. Oh, okay, it's a line. But the question is, what is the line? So you have to actually go through and divide this by a method that you know how to do. So how do we actually divide this? Well, I like to use synthetic division. Synthetic division can be used if your leading coefficient is 1 on your bottom and It's linear. See, 1 and 1. So then remember, for synthetic division, we set the bottom equal to 0 and we solve, everyone. This is just the process of synthetic division. This is why we took 1010, and they revisited this in the first unit of 1050. So we need to do synthetic division. With synthetic division, we put our coefficients 1, 2, and -3. You guys remembering how to do synthetic division? Add straight down, multiply up, add straight down, multiply up, add straight down. Remember, if we do synthetic division correctly, the final thing would be the remainder. Do you guys agree? For graphing purposes, our remainder can be ignored. So you literally just ignore it. So then write the answer. What is the line? Y equals 1x minus 2. Then from there, you would go graph your slanted asymptote. Instead of horizontal, it's not horizontal. It's slanted. It's a line. So then remember, this is the y-intercept, and then this is the slope. So we would go graph -2, and then we'd go up 1 over 1, up 1 over 1, up 1 over 1. So just little things to remember. All right, look at this one right here. So we would have 2x cubed divided by x. What does that simplify to be? 2x squared. That's not 0. If you plug in a billion, you're not getting 0, are you, everyone? Okay, so this is a quadratic asymptote. So we would have to go through and figure out the quadratic asymptote by doing synthetic division again. And we actually practice this a lot in the next lesson. We just graph more next time, and they have a lot more slanted asymptotes. So we're gonna move on from here. We're getting the 3 scenarios. What if it would have been 1 over 2x squared? What's the difference in that versus that? What would this one be for horizontal asymptote? 0. 1 divided by 2 billion squared. You guys see, one piece of bread cut up into a billion times a billion pieces is 0. So there's an x on top. It's non-horizontal, I should say. Sorry. If the x is on bottom, it's 0. All right, let's just start practicing these. Here we go. So we're just going to get right to the point because we really just don't have time to do anything else but get right to the point. So we're going to graph this. I need you to follow. I wrote the steps for you above. We're just going to do the steps as we go. So your first step is to factor the top and bottom and find your horizontal asymptotes. So let's write this down. You got to take really good notes from here on out. Horizontal asymptotes come from the bottom restrictions. So what is our restriction here? What? -2, right? We set it equal to 0, everyone, and subtract 2. You with me? And that's not enough information. You need to say right now if it's going to go in the same or opposite directions. How many times did that restriction show up? Once. So you're going to go in opposite direction. That's only helpful once we get started. We're going to go to -2, draw in our vertical asymptote, and that does shape our graph. This is a domain restriction, so it doesn't get crossed. We then go on to our next step, which is, what did I say? Why am I saying horizontal? Vertical, forgive me. Vertical asymptote. I shouldn't have been using the word horizontal. I hope you can forgive me. Are you mad? Because now I'm freaking confusing everyone. All right, horizontal asymptotes are found by doing leading term divided by leading term, simplifying it and seeing what you get. If I were to plug in a billion, 4 divided by a billion approximately is 0. So we would go do a horizontal asymptote at 0. Now, don't be mistaken. Horizontal asymptotes can be crossed. So don't say, because it's at 0, there's no x-intercept. No, sometimes there's going to be x-intercepts because the horizontal asymptote only guarantees that we will approach it at the ends of the graph. It doesn't guarantee there won't be an x-intercept. Now look, this is what shapes our graph. This red and pink dotted line. The question is, though, we got to get started. So we've got to have a point. Now listen what I recommend. Couldn't I make an XY chart and just start plugging in a bunch of values? Sure, right? I could. But I would find easy points. And they also ask on the test sometimes that you get these points correct. So let me tell you what points. The easiest points to find are x-intercepts and y-intercepts. So x-intercepts are when y equals 0. Y equals 0. Remember, f of x is y. So we're going to say 0 equals 4 over x plus 2. We then solve for x. Now look at this. If we always have a rational set equal to 0, and I say make it not a fraction, won't our first step be to take the bottom and multiply it to 0, everyone? So we're going to take that and times it by 0. What's 0 times anything? 0 equals 4. So think about it. The bottom goes away, and it's going to do that every time. X-intercepts come from the top. Why? Because the bottom multiplies up to the 0. That's your first step every time. Do you guys see what I'm saying? If you always set it equal to 0, you're going to take the bottom and multiply it to 0. So it actually always comes from the top. So in this case, is there even an x-intercept? Can you solve for x here? Isn't it a contradiction? So you're going to say none. Now that is important. You better not cross the x-axis or you definitely get it wrong. Well, that's not helpful to get started, so I need to try a y-intercept. We need at least 1 point. Y-intercepts are also easy to find because it's x equals 0, so you just go plug in 0. So that'd be 4 divided by 2, which is 2. So we do have a point now, 0, 2. Y-intercepts always cross. There's not a y-intercept that bounces, really. So now from here, look, this should be your thought process. There's graph on the right side of the vertical asymptote and left side. Let's start on the right side. I always start on the right side, and I say, okay, do I have a point that tells me what's happening? Yes, the y-intercept. Now we're either going like this in purple, or we're going like this in green. Asymptote shape. So is purple making more sense or green? Purple. Green? Wouldn't green head in the direction of the vertical asymptote to cross? Well, that can't cross. You can't cross vertical asymptotes, so it must be purple. So draw purple in, head to your asymptotes. Anytime you have one side of the asymptote drawn, the next step should be drawing in the other side of the asymptote. Didn't we say it would go in opposite direction? Yeah. So what you're going to do is start by saying, I go to the other side of the asymptote and come down. Start by drawing in that. Then from there, you're going to start tracing. So here I am going back to purple. Now I just start tracing, and asymptotes are giving you shape. So wouldn't it make sense that I head to my asymptote? And I'm done with the problem. So pretty easy, but you do have to be able to think a little bit. Let's do another one. They get a little more advanced each time. That one was a really basic one. Okay, first things first is factor the top, factor the bottom. In this case, it's factored. So then we move on to vertical asymptotes, which come from the bottom restrictions. So if we set 3x minus 1 equal to 0 and solve, we add 1. 3x equals 1, divide by 3. X equals 1/3 is the bottom restriction. So that's my vertical asymptote. Didn't it happen one time? Yeah. It wasn't 3x minus 1 squared. Happened once, which means it's going in opposite direction. So let's go to 1/3 and do our dotted line up like this, and this will never be crossed. If they said what's your domain, you would say negative infinity to 1/3, 1/3 to infinity. And we write ourselves a note. I like to write it right by the asymptote. Then I need, to take shape, I need my horizontal asymptote, which is leading term divided by leading term. So what does that simplify to be? 1/3. So we go up 1/3 and do our purple dotted line here. We now need to get started with some easy points. X-intercepts are always what I recommend using, and Y-intercepts. X-intercepts are Y equals 0. So we do 0 equals X minus 5. Why did I just do the top, not the bottom? I'm asking again. Yeah, the bottom multiplies up to the 0 every time. So yeah, X-intercepts are the top solutions, So now solve for X. Add 5. 5 equals X. Look, we have a point. 5, 0. Now that's not enough information, you guys. You have to get it in your head that at asymptotes, like vertical asymptotes, you have to write whether it goes in the same and opposite direction. And same with x-intercepts. Look, x-intercepts bounce or cross. If it happens once, 3 times, 5 times, it'll cross at the x-intercept. If it happens twice, 4 times, 6 times, it'll bounce at the x-intercept, which totally changes the graph. So you have to write yourself a note. It's going to cross at 5, 0 since it happened once. This is also wildly important, you guys. That is the only place you can cross the x-axis. Do you know how many kids will get all this and then they'll draw a graph and then they have their graph crossing in some random place at the x-axis? That is the only place we can touch the x-axis. All right, let's do y-intercept. Y-intercept is x equals 0. So that'd be 0 minus 5 divided by 0 minus 1, which is 5. We plugged in 0, got out 5. Over 0, up 1, 2, 3, 4, 5. This should be your thought process, everyone. So watch. I say I need graph on the right side of the asymptote, the vertical asymptote, and the left side. Let's start on the right side of the vertical asymptote. Don't we have a red point? Now this is where you have to be good at scenarios. Watch the 2 scenarios. We know we're crossing through. So in green, watch. It's either coming up from, let me draw this a little prettier, even though it doesn't matter. It's either coming up, crossing through, and then headed back down to the asymptote. That's case number 1. Or couldn't we be coming down from this asymptote, crossing through, and heading back up to the asymptote like that? Yes. So which one is possible and which one's not possible? Can anyone tell me? Is it green or blue? There's a very specific reason of why one is an absolutely not.
I think it's green.
It's for sure green
So
because,
the opposite of that side.
oh, but we don't know that other side. So that's actually not the reason. There's a different reason. For sure it's not blue, everyone. I repeat, it is for sure not blue. Why for sure?
Because you cross the
Yes. Can you just cross the x-axis any old place you want? No, absolutely not. Do you guys agree blue would have to cross the x-axis to get back to the asymptote? So that is usually the reason you can eliminate one of your options. Oh, blue crossed the x-axis again. You can't just cross the x-axis anywhere you want, so it's definitely not blue. Is that making sense now, everyone, now that you connected that dot?
How did you know it was like that shape?
You don't. That's my point, though. But can horizontal asymptotes be crossed? Yes or no?
Yeah.
So what if I look at somebody's test and they went like this? Isn't that accurate as well? Yeah, we don't know if it crosses or not crosses. It doesn't matter. Okay. Either way, though, blue wouldn't have worked, right? Because blue would have had to head back to the asymptote. Do you guys see what I'm saying? Okay, so now let's jump to the other side. Always don't go to the red point on the other side. You shouldn't be. You should be drawing the other side of the asymptote. Didn't we say it goes in opposite direction?
Yeah.
This one's down, so go to the other side of the asymptote and go up. See, watch. Start up here. Okay, now I start with purple and I start tracing. Now, aren't I headed to the red dot? Do y-intercepts bounce or cross? Y-intercepts. They cross. There's no bouncing y-intercepts, so cross through. Well, then where am I headed? To the asymptotes. That's what gives us shape. So when I head to this asymptote like that, and that would be accurate. Are there questions on that? So it's just hard at it just takes some practice getting good at looking at the first, once you get started, it rolls. But a lot of times the first scenario, it's like, oh, which one could it be? And sometimes you're like, actually both work. So you'll see that happen. So then you have to find another point. Here we go, everyone. The first step you do is factor the top, factor the bottom. Well, okay, then I have x plus 1 on top and x minus 1 on top. And then, yes, I am jumping to the factors for quickness purposes. I do expect you to know how to factor. On bottom, we would pull out an x, and then we would have a quadratic that then factors to be x plus 2 and x plus 7. So the first step is factor the top, factor the bottom. Do I expect you to factor that quickly? No. I'm just jumping there. Is everyone okay with that? So then you would say vertical asymptotes come from the bottom restrictions. So what would it be? 0 and -7. And they all happen one time. You can't just say vertical asymptotes. You're not going to get it right. You have to say whether they go in the same or opposite direction. Aren't they all happening once? So they are going in the opposite direction. So go draw in your vertical asymptote at 0 and at -2. These will definitely not get crossed. These vertical asymptotes can't get crossed because they're domain restrictions. And at -7. Now we need our horizontal asymptote because that's what's shaping us. Horizontal asymptotes are leading term divided by leading term. So you don't want factored form. You want this standard form. The leading term on top is x squared. The leading term on bottom is x cubed. So that's xx over xxx. So won't that be 1 over x? So again, if we plug in a billion, won't we get y equals 0? So go draw that in. This is a really good one to see. Now we've got to get started. Oh, let's write ourselves a note too. Opposite, opposite, opposite. I like to write it right by my asymptotes, okay? All right, now from here, you need some x-intercepts and some y-intercepts. And maybe you'll want even more points than that. We'll see. X-intercepts come from the top equal to 0. So you're going to pick factored form, because then solving is easy. Then we could set x plus 1 equal to 0 and x minus 1 equal to 0. So x equals -1 and x equals 1. But wait, that's not good enough. You have to state whether they cross or bounce. X-intercepts can bounce. In this case, do they cross or bounce? They happen once, so they cross through. So go to -1, put a dot, and we know it's going to cross through. Go to 1, put a dot. We know it's going to cross through. Let's do y-intercept. That's plugging in 0. Now, actually, wait a minute. If I go try to plug in 0, I'm going to get a divide by 0 on bottom. If you look, plug in 0. Can we divide by 0? Ever? No. And that makes sense. Isn't the vertical asymptote at 0? So vertical asymptotes are for sure restrictions. So you'd say, actually, there is none. There is no y-intercept. There wouldn't be a vertical asymptote there. Now watch, because this is the hardest part for kids. It's getting started, and it makes sense why it's hard. Okay, it used to be hard for me. So watch me go to the right side of this vertical asymptote. That's where I start. I move my way across the asymptotes. So look at scenario number 1. So asymptote shape. So I'm either coming up, and should I cross through? Did we say cross? So it's going to cross through and then head back to the asymptote like that, or in red, it's going to come down, cross through, and head back to the asymptote. Do you see any issue with either? No, both work. But in real life, they both don't work. Just in this theory right now, they both work. So think about what we could do. Couldn't we say, well, since both work, I need to know which one actually is the correct one? Think about it. Couldn't I go plug in, like, for example, 3? Yes? And if I plug in 3 and the value is positive, it's up here. And if I plug in 3 and it's negative, it's down here. And so then won't we know whether it's red or blue? So I have to say, oh, you know what? I'm forced to go plug in a value to the right. So if I go plug in 3, that would be 3 squared minus 1 divided by 3 cubed plus 9 times 3 squared plus 14 times 9. Oh, 3. Now, isn't that 9 divided by a positive number? Do I even care what the number is? No. Is that a positive or a negative? Positive. 9 divided by a positive number. Do I really care what the value is? No. I know that it's positive. So will it be blue or red? It's for sure blue. We just plugged in 3 and got out a positive number. So we know it's blue. So we got to draw in our blue. Do not go over to the green point next. That will confuse you. What you always do is once you have one side of the asymptote drawn, you go to the other side and draw it either in the same or opposite direction. So look, down here, it's down. On this asymptote, it's down. Didn't we say it's opposite? So your next step would be going to the other side of the asymptote and going up. So that's what I start with. Look, my purple arrow thing up here. Now I'm going to start tracing in blue. So then I trace down, down, down. Shouldn't I be headed to the x-intercept? And you said we cross. So when we cross through, we know we're headed to this asymptote over here. Why? For one, you can't go like this at an x-intercept and head backwards, because that would be double dipping. Do you guys see what I'm saying? And for two, even if you did head back this way to this asymptote, then you'd be going in the same direction at this asymptote, which we said it was opposite. Now look, watch how easy the rest of the graph's gonna go. We now say, since we have this side of the asymptote drawn, we know it's opposite. Shouldn't I then go to the other side of the asymptote and go up out of it? And then you just start tracing. Say, okay, so I'm tracing an asymptote shape. Am I allowed to cross again? No. There's no other x-intercept, so you must be circling back up to this asymptote. Once you have this side of your asymptote drawn, you would say, oh, well, I know it's opposite, so I know this one must be down. And then start down and start tracing. Asymptote shape, and I shouldn't be crossing the x-axis again. So like that. So you see, once you get going, it goes quick. Now, don't be this student. There's students that say, you said it was going to be opposite, and like these are going in the same direction. Those are different asymptotes, you guys. You know what I mean? We're looking at the one asymptote. At this asymptote, this one went down and this one went up. You can't let your eyes fool you. You know what I mean? They weren't going in the same, those weren't even the same asymptote. That's not what we're looking at together. All right, so we're done. Moving on to the next one. We just got to see tons of examples. Fact of the top, fact of the bottom. Okay, so the top really should be written as x plus 3 because we want it from highest power to lowest power. On bottom, you have to remember from 1010 how to factor two perfect cube roots. So let's review it. If you cube root x cubed, you get x. If you cube root 27, you get 3. Do you guys remember this? Then you do the front times the front, then the front times the back, then the back times the back. This is why we took 1010, so this wouldn't blow your mind right now. This is the front, this is the back. So what would be the front times the front? Then the front times the back. Then the back times the back. Good. Do you guys see how he did that? Then you had to memorize the signs all by themselves. So this was the process of the memorization of the signs of two perfect cube roots. The original sign, whatever it is, in this case it's a minus, the original sign will always go into the first linear, see, degree 1, first factor. We then memorized the next sign over is always opposite of that sign. So in this case, it'll be plus. We then learned the final sign is always, always plus. We also learned in 1010, in two perfect cube roots, the quadratic piece has imaginary solutions always, which means it doesn't factor any further. This is as factored as it gets. So now we're gonna go do if this is as factored as it gets, then let's go do our vertical asymptotes. Vertical asymptotes are bottom restrictions. So what's the restriction for the x minus 3? 3. It happens once. So it's gonna go in opposite direction. I just told you these are imaginary solutions, which means it doesn't factor. Imaginary solutions are not asymptotes. So you would say, that's it. That's the only vertical asymptote. I repeat, imaginary asymptotes aren't a thing. So that is the only asymptote. So go to 3. Draw that in. Writing myself a note, opposite. We now need our horizontal asymptote. I go back to standard form. I recommend you do the same. The leading term on top is x. It's not 3, it's really x. The leading term on bottom is x cubed. So isn't that x over x, x, x? So isn't that 1 over x squared? That's not quadratic. Plug in a billion. 1 divided by a billion. 0. So we're going to draw in our horizontal asymptote at 0. We then need to get started. Let's do x-intercepts. X-intercepts come from the top equaling 0. So I set the top right here equal to 0 and I solve. Negative 3 equals x. So negative 3 comma 0. Now, but wait. You cannot forget x-intercepts can bounce and they can cross. In this case, it happened once, so it crosses. It really does totally change the graph's shape when it bounces. And there will be some that bounce. We'll do one in just a minute. That means the only place you can cross the x-axis is right at that location. Then the y-intercept, we plug in 0. So that would be 0 plus 3 divided by 0 cubed minus 27, which is 3 over negative 27, which is negative 1/9. We plugged in 0 and we got negative 1/9. So now look, if I try to start on the right side of the vertical asymptote, everyone, I don't know if it's up here or down here, and couldn't it be either? Right? Yes or no?
Yes.
Could be either, right? There's no problems with either of those. So I could either go plug in a value like 5 or 6, but I don't want to do that. I have some points on the other side. I'm saying, okay, I guess I'll just start on the other side of the asymptote. So look at these green dots. They're part of the graph, so let's connect them. So where does it appear to be heading? To the asymptotes for sure. Aren't they shaping us? Now it came and you said it crossed, not bounced. Is that true? Yeah. So cross through and then head to your asymptote. So could I dramatically went like this if I wanted? Woo! As long as I come back to the asymptote, isn't it fine? Because we don't know. It could go boo and come back down. It just doesn't matter. But now that we know it's on the opposite side of this, we should be going like this, up. So now from here, I'm going to trace and follow the asymptotes. And we're done with that problem. So just lots of practice makes you get good at this. We're going to do a few more. I know we're going quick because we just need a lot of examples. You only get good at these at seeing a lot of them and going like, okay, that makes sense. That makes sense. Again, saying the same things over and over again. So look, because different things do come up. We factor the top, factor the bottom. Then we state the vertical asymptotes. The vertical asymptotes come from the bottom. So what are my two vertical asymptotes? X equals negative 2 and 2, and they both go in opposite direction because they happen once. The next ones will start going in like the same direction. So far, they're kind of going in. I feel like sometimes they consider it, the easier ones tend to kind of go in opposite directions, I would say. Now we need, and then I write myself a note, opposite, okay? Then we need our horizontal asymptote, which is leading term divided by leading term, which would be 3x over xx, which would be 3 over x, which would be what? 0 again. There's been a lot of horizontal asymptotes at 0. It's just a coincidence. They're not at 0 like all the time or anything. Now all we got to do is get started. X-intercepts are setting the top equal to 0. So 0 equals 3x. We then solve. So we'll divide by 3. 0 equals x. So 0, 0. That happens to be the x and y-intercept, you'll notice. So if I even try to find the y-intercept, I'll just get 0, 0 again. So look, wouldn't you agree, if we start on this side of the asymptote, it's up here or down here like that? And you can't use the point to say opposite. That's just not how it works. So it's like, well, which one is it? We really don't know. Like, I don't know. So I would have to go plug in a value and calculate it, and then I'll know where it goes based on the y value that turns up. So let's go plug in, I don't know, 4. So if I plug in 4, that would be 3 times 4, which is 12 on top. If I plug in 4, I get 16 minus 4, which is 12 over 12, which is 1. So I plugged in 4 and got 1. So we now know it's up here in this location. Now from here, it should always go very quick. If you get started, you shouldn't be messing up from here because you're going to use the opposite direction thing. So you're going to say, since this one's up, this one must be down. A common error is kids will try to go to the point, and I don't recommend it. So now from here, they try to go to the point and trace from there. Now from here, I'm tracing. Shouldn't I be headed to the y-x-intercept here? And you cross because it was once. So if I cross it, I'm headed to this asymptote. Why am I not headed back, look in green? Why am I not going like this again, back to this? Then 2 things, that's double dipping and it's sharing the asymptote, which we said wouldn't do. So you're right, both are ways to say no. Now that you have this side of the asymptote drawn, go to the opposite side and go down. And then literally from there, the asymptotes will shape the rest of the way. So once you get good at this, you can see these are considered, honestly, these should be considered, once you get really good at these, some of your easier problems of your life. But it's funny because this is considered like the hardest lesson to teach a junior. But I'm not going to lie, I really have perfected over the years. Like, I'm not bragging, but I teach this better than any teacher in the school. They should all come have a seminar and have me teach it. All right, thanks. All right, again, because you got to see, this one is finally where we get some bouncing going on. Not bouncing. This is where we get some same directional asymptotes. Okay, rewrite the top as negative x plus 2. The bottom factors to be x, and then x minus 3, x minus 3. Oh, good. This is good, because there's some new things coming up that haven't come up yet. My vertical asymptotes are the bottom restrictions. So aren't they at 0 and at 3 and 3? So we know that we go to 0, and we draw in an asymptote. And is it same or opposite direction? 0. It happened one time, so opposite. And then you're right. 3, though, is going to go in the same direction. That'll be helpful later. Now we do horizontal asymptote. Leading term on top is negative x. Leading term on bottom is x cubed. So that's negative x over x, x, x. So that would be negative 1 over x squared. If you plug in a billion, you get 1 divided by a billion squared, which is 0. Then we do x-intercepts, which come from the top equal to 0. So 0 equals negative x plus 2. I'm going to add x. X equals 2. But that's not good enough. I'm telling you, like, this is one thing even I used to forget to make note of. If my x-intercept bounces or crosses. Didn't it happen once? So it crosses. So go to 2 and we know it crosses. The y-intercept, we got to hurry and plug in 0. So that'd be 2 divided by 0. Oh, well, that makes sense. Isn't there an asymptote that's vertical there? So none. All right, so here we go, my friends. Watch, because this should be your thought process. If I try to start on this side of the vertical asymptote, it would either be up here like this or like this, and I don't know which one it is because both work. So you could go plug in a number. Let's say you plugged in 6. That would be negative 4 on top, and if I plug in 6 on bottom, I don't even care what number it is. Look, plug in 6. Is it going to be positive or negative? I'm going to just go to my calculator. 6 to the third, yes. Minus 6 times 6 squared. And then plus 9 times 6, it's a positive number. So what's a negative divided by a positive number? Isn't it a negative number, everyone? So I just know it's below. I go over 6 and I know it's some negative number down here. So now I know I can trace in below here. Now, you shouldn't be going to the red point. Instead, you should say it's in the same direction. So shouldn't I actually be down like this? And then you now start tracing, tracing, tracing. We know we're crossing through, so we're heading to this asymptote. We then are going to go in opposite direction, so we know we're down, which means then we're tracing along our asymptote. Yeah. We're now going to see the next one is really good because it actually has a 0 that bounces for once, and they're for sure going to put a test problem that has, you know, some a 0 that bounces because so many kids will mess it up and they like to separate the A from B student. So stick with me. We're almost finished the lesson. I promise we're almost finished. This will be our last graphing example. So our vertical asymptotes come from the bottom. I like it when they're already factored. It makes it quick. So aren't my vertical asymptotes at x equals -1 going in the same direction because it's squared, and then x equals 2 and it's going in opposite direction because it happened once. This is a really good one. This is like, it has like all of the advanced elements, I guess, that you'd need to remember to make it easy, I guess. So -1, we're going to write same, +2, we write opposite. Can you guys see my asymptotes? Do I need to draw them darker? Are we good? Horizontal asymptote, unfortunately, we do have to do the top divided by the top's leading term. Careful, what is really the top? Leading term. X cubed. There's 3 of them, right? Divided by on bottom, isn't it also x cubed? Which means it would be x cubed divided by x cubed becomes 1. Y equals 1. Now, we don't know if it's going to cross or not. That has nothing to do with anything here. That's not a trick here. We really just don't know. Now, we got to get started. X-intercepts are the top equals 0. Ooh, I love this one because it's something we haven't seen. Because it's factored on top, this is easy to find. You'll just set x plus 2 equal to 0 and x minus 3 equal to 0 and solve. So -2. X equals -2. X equals -2. Didn't that happen 2 times? So it's going to bounce. So I'm going to go to -2 and put a dot, and then I'm going to make myself a note. I got to bounce when I get there. And then at 3, we add 3. X equals 3. We're going to make ourselves a note. Once we get there, we got to cross through. And then I'm going to say, I dang well better not cross the x-axis anywhere. I better not even touch the x-axis anywhere but those 2 pink points. Now, watch from here, everyone, because this is tricky for kids. So let's go on this side of the asymptote and try to do the graph. Let's do both scenarios. We know we're crossing through pink. So asymptote shape. So watch. I'm either coming up like this and headed back. That appears to work, but that doesn't mean the other one doesn't work. So let's try the other one. And then we're coming down, crossing through, and headed back to the asymptote. So the answer is no. You guys said it so confidently. Why is it for sure not blue? Because then it would cross the x-axis again. So you'd say, okay, it's not blue, it's the green scenario. Once you get one side drawn, you should sigh a breath of relief because you now know that, look, you're going to go, I need to go in opposite direction. So I'm going to draw this. Now watch, because this, yeah. So aren't I coming down, down, down? Now don't be like, oh, I can't cross the horizontal asymptote. Absolutely wrong. Can you cross the horizontal? Yes. So look, I'm coming down and I'm headed to the x-axis here. Can I cross it though? Well, then I better head back up. You better not cross. Aren't we heading back up then? Okay. Now from there, we know we're going in the same direction. So you should be going now like this, up on the other side. As I trace down, I'm crossing the horizontal, which is fine. It has nothing to do with it. Shouldn't I be heading to my pink point? And luckily it bounces, because if it bounces, that's a good thing because then I can head back to my asymptote. If it would have crossed through, I knew something's off. Because then when I need to get back to the asymptote, I need to cross again. Yes.
Doesn't matter which side of the asymptote you're on to finish.
No. So let's say you would have went like this and dramatically drew it up and then came back down. Cool. It could look like that. We don't know what it actually looks like.
Stayed under.
Or stayed under. We don't know. Do you guys see what he's saying?
Yeah.
Like how dramatic do you draw what? And so he's saying, what if we would have went like this? Cool. Yeah, it's all the same graph. Because you haven't broke any rules. You haven't crossed any x-axes. So I do have a kid say, well, what if I drew this? And I mean, I can see what they're saying, not being new at this. They go like this and they go, well, I won't ever go up to the asymptote. I'll just stay like that. You have to go to the asymptote at some point. You know what I mean? You got to head back up there. Okay. So what I'm going to look for on the test is, are they out in the correct place out here? Yes. Have they crossed at the correct x-intercepts? Yes. And then y-intercepts is less important. I'm like, okay, everything, the asymptotes look good, the end behavior looks good, the tracing looks good, we're good. All right, do you guys feel like we can skip this one? All right, now last but not least is doing these ones, writing the equation. So we're going to do these are two separate questions. This is number 1. It says vertical asymptotes. These should be overall pretty easy. There's some tricky elements. So it says the vertical asymptotes are at these. Vertical asymptotes are bottoms. So make sure you do the opposite though, because when you solve it, you're doing opposite. So if it's at -4, the vertical asymptote, it'll be x plus 4 on bottom. If it's at -1, it's x plus 1 on bottom. Does everyone see what I'm saying? Where are x-intercepts located, top or bottom? It's been the top the whole time. Remember, x-intercepts are from the top. So make sure you use x minus 1 because it was x equals 1. So it'd be x minus 1. This will be x minus 5. Now that would be a good answer, but then they threw in, we need our y-intercept to be 0, 7. Do you know how many kids will just go like this, plus 7? That's wrong. If you put plus 7 out here, that doesn't mean your y-intercept's at 7. Whoever said the y-intercept is out there? No one. So you have to say, okay, let's say, pretend this is my answer right now. What is the current, this should be your question. What is the current y-intercept if I call that my answer? So y-intercept is x is 0. So you need to go plug in 0 and see what you're at currently. You just plug in 0. So on top I get 5, on bottom I get 4. So this time when I plugged in 0, I got out 5/4. Isn't it true that when we plug in 0, we actually want it to be 7, everyone? Now listen, it's actually a really easy fix. The only way you're allowed to change your problem but not change vertical asymptotes and not change x-intercepts is to times by a number. Literally, I'm allowed to times by a number because look, if I have some number in front like 8, that doesn't change the zeros and it doesn't change your asymptotes. So you're allowed to times by a number to fix it. So this is what you're going to do. 5/4 is my current y-intercept. I need to times by a number so that it equals 7. That's the only thing you're allowed to do is to take your current y-intercept, times it by a number to equal the correct one, which is 7. Now it's just basic algebra. You'll divide by 5/4. So the number you need to times by is 7 divided by 1 divided by 5/4. So I'm flipping my fraction and multiplying, which is 28/5. Apparently the number I need to multiply in front is 28/5. Now why did I put 28 on top and 5 on bottom? Because that's how multiplying fractions work. Doesn't the top one go on top and the bottom one go on bottom? We multiply straight across. So now look, truly, if you go plug in 0, you are getting 7 now because you added in the 28/5. And when I say added in, I mean multiplied in. Okay, let's do another one. See, look at the next one. It says vertical asymptotes at -4. So we have x plus 4 and -5. So you have x plus 5. These are my vertical asymptotes. It says these are my x-intercepts. So you have x minus 4 and x plus 6. Then it's telling you, it didn't say anything about y-intercept, but they said they want the horizontal asymptote to be 7. So if they want the horizontal asymptote to be 7, you do the same thing. You say, well, what am I currently at here? So to find horizontal asymptote, you do leading term divided by leading term, which on top is x squared, on bottom is x squared, it's 1. Now the only thing you're allowed to do is multiply by a number to get the correct thing. What do we need to multiply 1 by to get 7? 7. So you literally just multiply by 7. Why did I put it on top? Because it's really 7 over 1, right? And you multiply straight across. Do you guys see what I'm saying? So either way, if you're fixing a horizontal asymptote, you're going to multiply by a number that will make it the correct number. And if you're fixing the y-intercept, you're going to times by a number that will make the current one the correct number. Yes?
Would you ever need to like multiply like x minus 4 by itself? Like say the bottom was bigger?
Yeah, yes, but then that would change x-intercepts. They're not going to do any super tricky ones. They'll have them kind of unfold naturally because you're saying like, what if they said 0, so you need your power on bottom to be higher, but then you would have to, but maybe, I see what you're saying. Like, could you have put a squared on this and made it 0? Yes, you could do something like that because that wouldn't change the information either. So yes, I think they're going to overall keep it pretty simple though. Especially for the test, they'll keep it pretty basic. Okay, so look, this is our last problem of the day. I appreciate you guys because you've done really well. Let's just quickly do this one. So the first thing I do is say, what are the vertical asymptotes at? Make sure you write it out because it's easy to get it backwards. It's at x equals -3, which means it's x plus 3. This one's at x equals 4, so it's x minus 4. Those are my vertical asymptotes. The next thing I do is put x-intercepts on top. The only x-intercept is x equals 3, and didn't it cross through? So that happened once, let's say. So you'll say x minus 3. Could you actually go x minus 3 cubed? Yeah, but why would you make it harder? You want to make it as easy as possible. Then really, if you get that far, you've got majority of the points. Now, I am saying they did a prominent, very easy. If they went through a decimal value through the y-intercept, you're going to be like, we're going to hope it's good enough. But it is going through a whole number. So you would say, when I plug in 0, I need it to be -2. So you do the current thing. You say, well, when I plug in 0, what is it currently? So that would be 0 minus 3 divided by 0 plus 3 times 0 minus 4, which is -3 over -12, which is 1/4. So right now, when I plug in 0, I get 1/4. When I plug in 0, I need it to be -2. So what you're going to do is say, I'm going to take the current number, 1/4. I'm going to times by a number to make it equal the -2 that I need it to be. See, you said 1/4. I need to times by some number because I'm allowed to do that. And then it will equal the -2 that I need. So I'm going to times by 4 to both sides. The number you need is -8. So you'll throw a -8 in front. Multiplied. Why did I put it on top? Because really it's -8 over 1. So it ends up on top. And that will get us the correct thing. And you know, this is creating a horizontal asymptote at 0. Let's pray that it's already 0. Why is it 0? Because on top I have -8x and on bottom I have x squared. So that would be -8 over x. Do you guys see how it's 0 currently? And if you look at it, it actually is 0. See, out here it's approaching 0, and out here it's approaching 0. Okay, we're good then. So that would have been your final answer. So it is a lot, and honestly, you're really going to only get good at this with tons of practice. So I would understand, too, the bummer part is you're going to be doing 3.1 and 3.2's homework. Let me explain what 3.1 is. 3.1, they just verbally say, what are the vertical asymptotes? What's the horizontal asymptotes? What are the x-intercepts? What's the y-intercepts? They don't make you actually graph any of them. Then when you get to 3.2, it's just all graphing. So it's kind of like I would definitely do both because I just think both are wildly important for the test. Obviously, graphing is huge. So I guess some kids say like, well, if I can do 3.2, can't I do 3.1? And I'm like, yeah, technically, because didn't we answer all those questions as we went through all of these? You know what I mean? Do you guys see what I'm saying? So if you were going to if you were like, I insist, Mrs. Billman, on everything that I skip one of those, you cannot skip 3.2, the actual graphing ones. Because I agree, if you can answer all these, then you're answering what 3.1 is asking of you. I would just do both because I just would, but that's just me. Okay, ready, set, go. I know the bell's probably about to ring, isn't it?
Yeah.
Bless our souls. You guys are awesome.